Hello, good afternoon everyone guys. I welcome you once again to this wonderful channel by Unacademy NEET English. I believe you are doing great and having a good time. Well, my name is Kar Khurshid Alam and you can also call me KK sir. But before we move ahead, I want quick confirmation that if you can see me clearly and hear me clearly, let me know in the chats quickly. Let me know in the chats if you can see me clearly and hear me clearly. Let me know in the chats, quick. Am I audible and visible to each and everyone there? Okay, I believe we are live now. And in today's session, we are tackling the absolute backbone of organic chemistry. And in this very session, we are going to master every reaction of organic chemistry, that too in only one shot. Let me tell you that this session is going to be like a never before session. And I truly expect with today's session. And around 10 to 12 questions from this session will come in your NEET paper. So you have to be with me till end of this session. Just share the stream with everyone around and mark the attendance by smashing the like button. Now show some josh in the chats so that without wasting time we will start today's session. Now let me know in the chats, how is the josh? Come on, quick. Let me know in the chats, how is the josh, my dear lovely students? Quick. Quick. Because this session is gonna be very important. Because out of 15 questions, 10 to 12 questions will be from this session by one way or the other way. But 10 to 12 questions, I mean it. 10 to 12 questions from this session and I mean it. Okay, Josh is high. Very good. Josh is very high. That's great. That is great. Come on. So be with me till end and also share the stream with everyone there. Because this session is gonna be very important for all the NEET aspirants there. Okay, without wasting time, let's get going. So have a look. First of all, let us start with CH4. You know, CH4 is the simplest amine hydrocarbon. Now, whenever you are having CH4 and you treat it with chlorine in presence of what we call light or heat, then what will happen? What will happen over here? It will simply replace this hydrogen because this is free radical substitution reaction and it will result in the formation of CH3Cl. After that, my dear students, if we treat this with sodium in presence of dry ether, I mean to say Wurtz reaction, then what will happen? We have to break this bond and we will form simply CH3 radical over here, and then combination of this radical takes place and it will result in the formation of ethane CH3. That means C2H6 will be formed. After that, if this is treated with either, I mean to say, chlorine or bromine, so let me write down over here chlorine. You can write bromine as well. Now, so what will happen? This one of the hydrogens will be replaced by chlorine, then you will get CH3Cl. So this is very important compound, or you can say alkyl halides are the backbones. Now, have a look, my dear students. Say for example, we are having an alkyl halide, CH3CH2Cl. Then, which type of reactions will be there? Have a look. Now, We can simply do first reaction like this. If this is treated with alcoholic potassium hydroxide and we will heat it. Remember, this is an E2 reaction. Then what will happen? Simple alkene formation takes place. So, whenever you have alcoholic potassium hydroxide and alkyl halide form alkene, that means dehydrohalogenation will take place. You know that. So, this is simple what we call elimination reaction. After that, if you are having KOH, aqueous KOH, aqueous NaOH, or you are having, say water, you are having AgOH, then what will happen? Simply replace this Cl, because this is now an SN2 reaction, replace Cl by OH. So this will be an alcohol formation over here. Similarly, my dear students, if you are having NaSH, sodium hydrosulfide, then this SH will act as a nucleophile and it will replace this Cl and we will get this one. Similarly, if you treat this alkyl halide with NaSR, or you can say sodium mercaptide, then what will happen? This Sr minus will act as a nucleophile. Nucleophilic substitution reaction of haloalkane or alkyl halide will take place and it will result in the formation of this one. This is thioether, because this is R, S and R. This is thioether. Similarly, if you treat this with, say for example, methoxide or sodium methoxide, say alkoxide. Reaction of alkoxide with alkyl halide is simply Williamson's synthesis. So it will result in the formation of ether. Now, when this ether is obtained, have a look. When this ether is obtained, if you heat it with, let us suppose HI. What will happen? What will happen? Have a look. This ether is unsymmetrical. But if we take it with HI, say for example 1 mole only, then what will happen? This is an alkyl but not a tertiary alkyl. Similarly, this is an alkyl but not a tertiary alkyl. When oxygen is having alkyl groups attached to it but not tertiary, at that time a reaction with HX is simply SN2 reaction and this I minus goes to smaller alkyl group, so it will result in the formation of CH3, CH2OH and CH3I. But if this HI is taken in excess, then this alcohol also forms alkyl iodide. After this, have a look. If you treat this with phenoxide, say for example sodium phenoxide, this is once again Williamson ether synthesis or Williamson synthesis, then what will happen? This phenoxide ion here will replace the Cl and the product will be like this. But if this ether is treated with HI, whether HI is, say 1 mole or HI is, say taken in excess, then what will happen? Have a look. This bond will be broken. I goes to this and there will be one of the products will be always phenol over here. So it will result in the formation of alkyl iodide and we will get phenol over here. After this, my dear lovely students, have a look. If you treat this with KCN, say for example alcoholic potassium cyanide, here nucleophile is Cn minus, that means an ambidentate nucleophile or ambident nucleophile. We know Cn minus, in Cn minus there are two different donor sites, one is C minus and another is N having lone pair, but we know C is more stronger nucleophile and it can form more stronger bond, CC bond. So the major product of this reaction will be CH3, CH2 and then what we call C triple bond N. So with the help of this reaction, we can increase what we call number of carbon atoms. After this, if you are having this cyanide, then you can simply reduce this cyanide with the help of reducing agents. Say for example, lithium aluminum hydride, H2 in presence of Raney nickel, sodium in alcohol. Say you can use different reducing agents. So then this pi bond will be broken and it will result in the formation of a primary amine like this CH3, CH2, CH2, NH2. Have a look, my dear students. Similarly, if you want, you can convert this cyanide, you can treat this cyanide with SnCl2, HCl. After that, followed by hydrolysis. Then you have to, say this is known as Stephan reduction. At that time, Cn is converted to CHO group. So it is simply formation of aldehyde will take place. Similarly, my dear student, if you treat this with diabyl H, diisobutyl aluminium hydride, that can also convert cyanide to aldehyde. So today's session is very important because we will try to cover each and every reaction in today's session. Have a look. So this is what we call aldehyde formation takes place. But whenever you hydrolyze this, say for example, hydrolysis takes place either in acidic or in basic medium, but let me write down over here, acidic medium, then convert this CN into COOH. That means you will get carboxylic acid. But my dear lovely students, if hydrolysis is partial hydrolysis, at that time partial hydrolysis of cyanide will form amide, CONH2. And you can use simply reaction known as Hoffman-bromamide degradation reaction. Then what will happen with the help of this or NaOBr, or you can use KOHBr2? What will happen? You have just to remove this CO and you will get an amine over here. So primary amine, you will obtain primary amine from primary amide. Similarly, my dear lovely student, have a look. If you want to convert, have a look. If you want to treat, say this alkyl chloride with AgCN, this is a covalent compound. KCN is an ionic compound. Then here major product will be CH3, CH2, NC. Isocyanide will be the major product. After that, my dear student, if you want to treat this with KNO2, potassium nitrite, once again this is an ionic compound and major product of this reaction will be, it simply replaces this Cl by ONO. Say nitrite, alkyl nitrite will be the major product. But if you use AgNO2, then what will happen? This Cl will be replaced by NO2 because this is a covalent compound. So you will get nitroalkane. Remember, this nitroalkane on, reduction, say for example, active metal and acid, then this NO2 is changed to NH2. So you can get CH3, CH2, NH2 as well over here. So after that, let me show other reactions of this CH3, CH2Cl in another, slide. But before that, let me know in the chats, how is the session going to be? Can you understand now? Session is very, very important because we are going to touch each and every reaction over here. But let me know, is this clear till now? Am I clear till now? Let me know quickly. Okay, that's great. Mobina is saying, thank you. Yes, Fahmid, thank you. Raghavi, thank you. Kanmani, thank you. Aesthetic is showing hot emojis, fire emojis, that's great. Zahra, yes sir, that's good. Great, everyone, great, nice. God bless you. Now after this, let me write down this CH3, CH2Cl in another slide. CH3, CH2Cl is there. Now have a look. Let us show other examples of this. First of all, let me write down over here, say for example, CH3COOAg, silver salt of carboxylic acid. Now, its negative part will replace the Cl, so we will get CH3COO, and then this will be attached to CH2 and then CH3. So this is an ester. But if ester is treated with Grignard's reagent, say for example, CH3MgBr, we need at least 2 moles of this. And after hydrolysis, what will be the product? Product will be simply CH3, C, it's OH, then it's CH3, then it is CH3. So tertiary alcohol, we will obtain tertiary alcohol over here. Similarly, if you treat this with NaC triple bond CCH3, then what will happen? This is having a positive charge, this negative part will attack this and Cl will be lost. So we will get CH3, CH2, and then it is C, triple bond C, single bond CH3. So an alkyne will be obtained. And you know, in alkyne, you can do simply what we call Koch-Arrows reaction. That means hydration of alkyne. Hydration of alkyne can take place in presence of HgSO4 or H2 as well as H2SO4, dilute at high temperature 333 Kelvin. Now, what will happen over here? Major product will be this one. Major product will be this one. Major product will be this one. That means you can get a ketone over here. You can get a ketone over here. Have a look. This ketone on treatment with Grignard's reagent, say for example, CH3MgBr followed by hydrolysis, what will be the product? Product will be simply CH3, CH2, then CH2, then C, then CH3, then here it will be once again another CH3, then it will be OH. I mean to say this will be the product. This will be the product. Tertiary alcohol will be the product. After that, have a look. If we treat this with, say Grignard's reagent, say for example CH3MgBr. We know in Grignard's reagent, this is having a negative part, this is having positive part. Negative part will simply replace this. So we will get, let us suppose this is CH3MgCl. Suppose this is CH3MgCl. MgCl2 will be lost. So we will get CH3, CH2 and then CH3. Say alkane formation takes place over here. After this, my dear lovely student, have a look. If this is treated with sodium, in presence of dry ether, Wurtz reaction, what will happen? Dimerization of this alkyl will take place. That means it will result in the formation of N-butane or butane. Similarly, if this is treated with zinc, I mean to say Frankland's reaction. Now what will happen? Once again dimerization will take place. First it will form Frankland's reagent and then Frankland's reagent will result in the formation of this. When this is treated with, say for example CH3 whole 2 Cu Li, say dialkyl lithium cuprate known as Gilman's reagent, then what will happen? This alkyl will replace the Cl, then this results once again in the formation of an alkane. So have a look. Similarly, if this is treated with, say for example Mg, magnesium, in presence of ether tetrahydrofuran, then what will happen? Over here? CH3, CH2 and Mg will be incorporated between C and Cl, so it will result in the formation of MgCl. But this is alkyl magnesium halide, once again a Grignard reagent. This is negative part, this is positive part. If this is treated with any acidic hydrogen containing compound, say for example water will lose H positive and that H positive will be accepted by this one and it will result in the formation of an alkane. This reaction is known as Zerevatinov's reaction. You know that. So first I have shown elimination reaction, then I have shown its substitution or nucleophilic substitution reactions, few of nucleophilic substitution reactions. After that, I have shown reaction with different metals, then what will happen? After this, I will show over here halogen exchange reaction, say for example, sodium iodide and acetone. Then, my dear student, what will happen? The Cl will be replaced by I. This is known as Finkelstein reaction. After that, if this is treated with heavy metal fluoride, say for example AgF, then this Cl will be replaced by F. So what will be the product? Product will be CH3CH2F. These are halogen exchange reactions. Then similarly, if we want to reduce this alkyl halide, say for example zinc in presence of acid, not necessary zinc. Say active metal in presence of acid, or you can say zinc in presence of base, or you can say simply that Hi in presence of red phosphorus. Say reducing agents. So these reducing agents will replace the Cl by H, so the product will become CH3CH3. Similarly, you can write down lithium aluminium hydride. That can also reduce this to corresponding alkane. So it will result in the formation of this alkane. In nutshell, have a look. If you want to convert methane into, say for example, methylamine, say for example, acetamide, say for example, this amine, say propanaldehyde, so or propanol, then you can simply use these reactions easily. So I hope this is clear till now. Is this clear till now? Is this clear till now? Come on. Come on, my dear lovely students, show some josh. Show some josh, because in today's lecture, we have to cover each and every reaction. Each and every reaction. And in this session, in today's session, let me once again assure you that 10 to 12 questions of organic chemistry out of 15 questions will be asked in your NEET 2026. Come on. Thank you very much, beta. Love from Kulgam. Thank you, beta. May Allah bless you. May God bless you. Okay, that's great. That is great. That is great. Okay. After this, have a look. This is very, very, very important compound. This is very, very important compound. This is known as alkene. So alkene is very important compound, but this is symmetrical alkene. Let us try some reactions with unsymmetrical alkene. Say for example, this is an unsymmetrical alkene. Let us suppose this is an unsymmetrical alkene. Let's try few reactions with this. Let's try few important reactions with this. Have a look. Remember these reactions forever. Have a look. Tell me what will happen. If this alkene is treated with HX. I mean, say HF, HCl, HBr, HI. But in absence of peroxide. Or it is HF, HCl, HI, not HBr in presence of peroxide. Whether HF, HCl, HBr, HI in absence of peroxide, or HF, Cl and HI in presence of peroxide. Reaction will be electrophilic addition reaction, and intermediate of this reaction is carbocation, and the product formation takes place according to Markovnikov's rule. That means negative part goes to that carbon-carbon double bond which is having lesser number of hydrogens. So this will be the product. But if same reaction takes place but with HBr, in presence of peroxide, then this is not electrophilic addition reaction. At that time it is free radical addition reaction, and intermediate of this reaction is free radical, and product formation will be anti-Markovnikov's product. That means opposite to that of Markovnikov will take place. So the product will be like this. That means X to this and H to this, opposite to that of first product. So if I write this in this fashion, because CH3 is like this, so you have to replace H and X, negative and positive part. So this is what we call anti-Markovnikov's product. After that, if you want to add water, that means hydration in acidic medium, then once again reaction takes place via more stable carbocation, or according to Markovnikov's rule, and reaction is electrophilic addition reaction. So product will be like this. Similarly, if you want to react this with H2SO4, concentrated or cold concentrated H2SO4, then what will happen? Have a look. Once again an electrophilic addition reaction, then negative part of this addendum means HSO4 minus or OSO3H minus will go to that carbon-carbon double bond which is having more number of which is having lesser number of hydrogens. But remember, if this is treated with water and is boiled water, say for example, then it will simply replace this OH minus, negative part of this will replace, say OSO3H minus. So the product will be once again an alcohol. So product will be like this. If reaction takes place with, have a look, say for example halogen, let me write down bromine in inert solvent or non-polar solvent, then you have to add bromine across carbon-carbon double bond. But remember, this bromination is anti-addition reaction, and remember, reddish brown color of bromine during this reaction is decolorized, hence this reaction can be used as a test for unsaturation as well. Now, after this, if you use bromine water, Br2H2O, or you can say it is hypobromous acid, I mean to say HOBr, then what will be the product? Product will be once again like this. Say for example, product is like this. That means addition of OH and Br takes place according to, I mean to say, anti-addition. This is basically an anti-addition reaction. But have a look. OH is having slightly negative charge and Br is having partial positive charge. So negative part goes to that carbon-carbon double bond, which is having lesser number of hydrogens. This reaction is electrophilic addition reaction, these two, but taking place by a non-classical carbocation. There will be no rearrangement at all. Similarly, my dear lovely student, have a look. If you use this one, B2H6, THF, tetrahydrofuran is the solvent. After that, H2O2 in presence of OH minus. This is hydroboration oxidation. And you know, whenever your alkene is unsymmetrical and hydroboration oxidation takes place, you have to add water, but according to anti-Markovnikov's rule. That means your product will be like this. Anti-Markovnikov product. This one. So you can convert propene to propan 2-ol like this, or you can convert propene to propan 1-ol with the help of this. Similarly, if you use HgOAc, mercuric acetate and water, then NaBH4 OH minus. I mean to say oxymercuration, demercuration. That's also indirect hydration, but according to Markovnikov's rule. So it will be like this. Here OH will go to that carbon-carbon double bond, which is having lesser number of hydrogen, and this is oxymercuration, demercuration reaction. I hope this is clear till now. Now, after that, we will be having few other reactions of this. Say, for example, alkene. Let me show those reactions in next slide. But before that, let me know in the chats. Is everything clear to you? So this session is very important because each and every reaction will be revised. That means this is a very important revision class for you as well. Let me know quickly in the chats. Show some joy, show some, say green hearts as well. At the rate of NEET, KK is lit and good, serious. He is full of himself for me. It's an honor. Thank you very much. Okay, I will try to write with big letters. But basically there are many reactions and I want to basically cover whole organic chemistry reactions. That's why I want basically in one slide, if I write, say in big letters or say large letters, then it will be only 2 or 3 say reactions which will come in one slide. That's the reason. So I will try for you, don't worry. I'm always there for my lovely students, and at this time in front of me the future doctors are there, so I can do anything for you, my dear lovely students. So come on. Class duration will be 2 to 3 hours. We will finish this whole organic chemistry over here. Now after this, let me write down once again this propene. Say unsymmetrical alkene. Let me write down unsymmetrical alkene once again and show you few more reactions so that every reaction will be covered. Have a look. Let us start another reaction. And that reaction is, say for example, with dilute KMnO4. I mean to say Bayer's reagent. What is Bayer's reagent? Cold dilute alkaline aqueous KMnO4. Now what you have to do when your alkene is there and Bayer's reagent is there? You have to do synhydroxylation. Sir, what is meant by that? That is simply you have to break pi bond and you have to add OH and OH. You have to add hydroxyl groups, but from the same side. If this hydroxyl group is present on dash bond, that means behind the plane, this should also be present on dash bond, that means behind the plane. If one is above the plane, another should be above the plane. Similarly, same reaction, same product, I mean say, will be given by osmium tetroxide followed by hydrolysis. I hope this is clear. Now, after this, if you use per acid, it's not carboxylic acid, it's one oxygen more than that, per acid or per oxo acid followed by hydrolysis, Remember, my dear lovely students, this will be once again a hydroxylation reaction, but this hydroxylation will be anti-addition reaction. This will be anti-addition reaction. After this, if you use zinc, let me write down first, if you use, I mean to say, ozone and then zinc water, this is known as reductive ozonolysis. You have to simply break this bond and add oxygen to this, That means you will get CH3CHO and you will get OCH2. I mean say formaldehyde and acetaldehyde will be the product from this. Similarly, if you want to perform same ozonolysis but oxidative one, not reductive one, but oxidative one, then convert whatever aldehyde is formed during reductive ozonolysis, you have to convert that into acid. That means this will become CH3COOH and this will become HCOOH, but that is further oxidized and it will result in the formation of carbon dioxide and water. So this is oxidative ozonolysis. Remember, if you want to oxidize alkene by using KMNO4 in acidic medium or K2Cr2O7 in acidic medium, or my dear students, hot KMNO4, or my dear lovely students, hot K2Cr2O7. I mean say strong oxidizing agents are there. Remember, product will be same as that of oxidative ozonolysis. That means products will be like this. I hope this is clear. Let me know quickly, is this clear? Let me know quickly, my dear lovely students, let me know quickly. Am I clear till now? Is everything clear till now? Let me know quickly. Okay. That's great. That is great. Everything is clear. Nice. Now, we will be having few other example like this. We will be having few more reaction, say for example like this. For example, you will be having halogenation, say for example bromination, but by using NBS, N-bromosuccinimide, or you will be having bromination at high temperature or in presence of light. Then what will be the product? At this time, allylic bromination will take place. With the help of this. So you will get this one. I hope this is clear. These are the reactions with the help of which you can convert alkene to different, products. This is very easy. Now, let me know quickly. Am I clear? So that I will move forward. Let me know quickly in the chats. My dear lovely students, because this is very important session, and that too I assure you, I guarantee you, among this session, from this session, 10 to 12 questions out of 15 questions will come in your NEET exam paper directly or indirectly, by one way or the other way. So have a look. Now, after this, we will be having another important compound over here, and that is an alcohol. So let me show you this alcohol, because there is very little space over here. So that is why I will write down alcohol in another slide. Let me write down alcohol in this slide. Have a look, my dear lovely students. Have a look. So this is an alcohol. CH3, CH2OH. Say for example, this is an alcohol. Now, this alcohol can show many reactions. Say for example like this. This alcohol can show many reactions like this. Have a look. First of all, let me write down alcohol on treatment with. Have a look. Alcohol on treatment with this carboxylic acid in presence of acidic medium. Reaction is very important reaction, and that is known as esterification reaction. During esterification, you have to remove OH from carboxylic acid and H from alcohol. So the product will be, it will be CH3CO of this one because OH has been removed. Then here, remove this H, then it will be O, and then it will be CH2OH. Sorry, CH2CH3. But let me tell you, if this is O18, then O is this one. O18 is this one. That means it is basically CO, CH3RCO from this and OR from this one, esterification. After this, if this is treated with, say for example, acetyl chloride, then what will happen? Once again, this H will be replaced by this acetyl group. That means acetylation of alcohol will take place. So I can write down this once again, CH3CO, and instead of this H, it is O. Obviously, it will be 18, and after that, it will be CH2CH3. Now, let me erase this 18 over here, because otherwise I have to write down 18. So let me erase this 18 over here, and let me write 18 in this. That means we will get water over here, and in that water oxygen is O18 because OH came from this and H came from this. Okay, once again an ester is formed. After this, if I write CH3CO whole 2O, I mean say acetic anhydride is there. Now replace once again H by acetyl group. So you will write CH3CO and then this O and then CH2CH3. Once again an ester is obtained. After that, my dear lovely students, if this alcohol is treated with, HX can be HCl, HBr, HI. So let me write down over here, as you know that among HCl, HBr, HI is more reactive, so let me write down HI over here. So what will be the product? Replace OH by I, so the product will be CH3, CH2 and then I. After this, if you are having PCl5, so replace OH by Cl, so the product will be CH3, CH2Cl. Similarly, my dear lovely students, have a look. If you replace this OH once again by Cl, you have to write down PCl3. If you want to replace OH by Br, then you can write down PBr3 or Br2 in presence of red phosphorus. Similarly, if you want to replace this OH by I, then you will write down iodine in presence of red phosphorus. So I mean to say, you have to replace this OH by halogen. So the product of this reaction will be once again this. After this, if you use SOCl2, then reaction is known as Darzan's procedure. Once again, OH will be replaced by halogen, that means Cl. If this alcohol is treated with H2SO4 or H3PO4, I mean say acid, with protonic acid like H2SO4 or H3PO4, but at a temperature of 443 Kelvin, and if this is treated with same reagent but at lower temperature, have a look. Higher temperature favors its elimination and lower temperature favors its substitution, or you can simply say at this temperature this alcohol undergoes intramolecular dehydration. That means it results in the formation of alkene, having this one, intramolecular dehydration. But here intermolecular dehydration, that means dehydration between the two molecules of alcohol will take place and it results in the formation of symmetrical ether. Now after this, another reaction will be simply oxidation of alcohol. Now, listen carefully. Oxidation of alcohol can take place by two methods. Either by using MOA, I mean say mild oxidizing agents like what we call Colin's reagent, Seret's reagent, or PCC means Corey's reagent or pyridinium chlorochromate. You can use PDC, that means pyridinium dichromate, or you can use CrO3N, I mean say non-aqueous medium or anhydrous medium. So let me write down over here, very important among them is PCC. So let me write down over here. So remember, primary alcohol, as this is primary alcohol, it results in the formation of aldehyde at that time. It results in the formation of aldehyde at that time. After this, my dear lovely student, have a look. And this is very important compound. This is very important compound, and we will take this compound separately. Now have a look, have a look. If we use strong oxidizing agent, so what is this PCC? This is mild oxidizing agent, and let me write down our strong oxidizing agent. But I will not write down oxidizing agent, I will tell you strong oxidizing agents. Strong oxidizing agents are KMnO4, K2Cr2O7 in acidic medium, or KMnO4 in alkaline medium, or KMnO4 say in neutral medium, or you can say HNO3, concentrated HNO3, or you can say CrO3 in aqueous medium, that means CrO3 plus water, that means H2CrO4 means chromic acid. You can also use CrO3 plus H2SO4 means Jones reagent. So I mean say any reagent can be used over here, but remember primary alcohol at that time is oxidized to carboxylic acid. It is oxidized to carboxylic acid. I hope this is clear till now. Let me know in the chats quickly so that I will change the slide and will show some few more reactions. Let me know quickly, is this clear? Let me know quickly, is this clear till now? Okay, great, that is great, that is great, that is great. Let me know quickly. Is this clear till now? Is this clear till now? Thank you, thank you, thank you, thank you everyone. This is very important session. Very important session. Come on, my dear lovely students, come on. Okay, clear sir, clear sir. Okay. Yes, carboxylic acid will be obtained over here. Now, after that, let me write down once again this alcohol. And remember this is an alcohol, and this alcohol can show few more reactions like this. This alcohol can show few more reactions in addition to these reactions. What are those reactions? You can simply treat it with copper at a temperature of 573 Kelvin. Say hot copper. It undergoes dehydrogenation. This is primary alcohol. It undergoes dehydrogenation and it will result in the formation of aldehyde. Suppose this is what we call secondary alcohol. At that time, once again, secondary alcohol also undergoes dehydrogenation, but at that time it will result in the formation of ketone. Tertiary alcohol undergo dehydration, results in the formation of alkene. And another very important reaction is haloform reaction. Say for example, if you treat it with NaOH, if you treat this with halogen in presence of NaOH, if you treat this with halogen in presence of NaOH, and let us suppose that halogen is iodine, or you can simply say NaOI, then what will happen? What will happen, my dear students? Simple. This is, the position which is known as alpha. Break this methyl and alpha. Simply convert this CH3 into CHI3. Convert this into CHI3. Have a look. So product will be CHI3, and this is iodoform. Its color is yellow. So this can be used as a test, iodoform test. Plus convert CHOH into CONA, and H is there, so it is HCOONA. So I hope this is clear till now. This is clear till now. Let me know in the chats quickly. This is clear or not? Is this clear till now? Let me know quickly. Let me know quickly, my dear lovely students. Let me know quickly. Okay. That is great. That is great. Now, as this is very important, but we don't have much space over here, so let me write down another reaction that is of CH3CHO. This is aldehyde. This is aldehyde. Can I write this aldehyde in this fashion? We can write down this aldehyde like this. Have a look. Have a look. Have a look. We can show few reactions of aldehyde in this fashion. Let me show few reactions over here. First, let us say this is treated with HCl in presence of basic medium. What will happen? It will simply result in the formation of CH3, COH, and then CN and then it's H. I mean, say it will result in the formation of cyanohydrin. It will result in the formation of cyanohydrin. Is this clear? Is this clear? After that, my dear student, if it is treated with NaHSO3, sodium hydrogen sulfite or sodium bisulfite, it will result in the formation of this. It is OH, and then here it will be SO3Na. Similarly, if this is treated with CH3MgBr, I mean say Grignard's reagent, what will happen? Followed by hydrolysis. It will result in the formation of this. A secondary alcohol in this case will be obtained. Similarly, if this is treated with methanol but in excess, in presence of acidic medium, then we will get acetal. We will get acetal over here. We will get acetal over here. After this, my dear student, if this is treated with H2N and then G, let me write down over here the values of these G. G can be simply H. This G can be, I mean say NH2. G can be, my dear students, R. G can be, I mean to say OH. This G can be simply NH and then phenyl ring. This G can be NH and then phenyl ring. And in this phenyl ring, we will be having NO2 at this second and fourth position. Similarly, this G can be NH, then CONH2. So, you can accordingly form the product. So, have a look. This two hydrogens and oxygen will be lost. Then it will result in the formation of CH3CH from this, because oxygen has been lost, hydrogen has been lost. Now, N-double-bond-G. So, have a look. If G is H, then we will get imine. If G is NH2, then this is known as what we call hydrazone. If G is R, then it is known as Schiff's base. Then if it is OH, then it is known as what we call oxime. If this is NHPH, this is known as N-phenylhydrazone. If it is this one, then we will get 2,4-dinitrophenylhydrazone. Now, if it is this one, then we will get semicarbazone. I hope this is clear. I hope this is clear. After this, my dear lovely students, let me reduce this alcohol. Say for example, lithium aluminium hydride. Let us reduce this, I mean say aldehyde. Whether by lithium aluminium hydride or by sodium borohydride or by H2 in presence of catalyst or by using sodium in alcohol, what we will get? We have to convert this CO into CHOH. So we will get CH3CH2OH. I mean say we will get alcohol. After this, we can simply convert this aldehyde into alkane. How? By treating this with HI, red phosphorus. So simply this will what we call remove this oxygen, and instead of that hydrogens will be there. You can convert this into alkane by using zinc amalgam in presence of acidic medium. This is known as Clemmensen reduction. You know what you have to do is you have to convert C double bond over to CH2, then product will become this. After that, you can use another reduction, that is Wolff-Kishner reduction. Say for example, hydrazine, NH2NH2, or you can write down N2H4. In basic medium, this reduction takes place and it will result in the formation of alkane. So these are few reduction reactions as well. After that, we will simply convert this aldehyde to carboxylic acid by oxidation. Then there are few more reactions. So let me write down those reactions in another slide. But before that, let me know quickly, am I clear? Let me know quickly, am I clear? So that I can move forward. Now, let me know quickly. Let me know quickly in the chats. Let me know quickly in the chats. I am watching your chats. I am listening to you. Come on, through chats. Okay, that's crystal clear. Crystal clear. Yes, sir. Yes, sir. Crystal clear. Emojis are there. Come on. Come on. Put more emojis. Put some, green hearts as well. Show very, very high josh today. Show very high josh today. Come on. Clear. Clear, clear, clear. Okay, without wasting time, let's move ahead. So, suppose we will be having this aldehyde. Okay, let me show you this on another slide. Let me show you the reactions on another slide as well. So this is an aldehyde. Have a look, have a look, have a look. Have a look. Have a look, my dear lovely students, have a look. So you will be having few more reactions like, suppose you will simply oxidize it with Toland's reagent. What is Toland's reagent? Ammonical silver nitrate solution. That means AgNO3 plus NH4OH. So what will happen over here? This aldehyde is oxidized and we will get a silver mirror over here. Similarly, with the help of Fehling's solution or with the help of Benedict's solution, we can oxidize, these are mild oxidizing agents, we can oxidize this aldehyde to carboxylic acid or salt of carboxylic acid. But here in Fehling's solution and in Benedict's solution, we know red precipitate of Cu2O is obtained. So these reactions can be used. You know, this is Toland's test shown by all aldehydes. But ketones do not show this reaction. Alpha hydroxy ketone can show this reaction, Toland's test. Or we can simply say formic acid can show this test. We can say N-phenyl hydroxylamine can show this test. We can say what we call hemiesters can show this test. Terminal alkynes also show this reaction or test, but there will be no silver formation. There will be no silver mirror formation, but white precipitate formation takes place at that time. But Fehling's solution and Benedict's solution is shown by aliphatic aldehydes, or it can be shown by what we call alpha hydroxy ketones or formic acids. Aromatic aldehydes do not show this test. Ketones in general do not show this test. Now, after this, my dear lovely student, have a look. If we use iodine, I mean say halogen, in basic medium, this is known as haloform reaction or iodoform reaction or simply iodoform test. What will happen over here? This CH3 will be converted to CHI3, yellow precipitate will be obtained over here. After that, this will be converted to HCOONA. So I hope this is clear till now. After that, very important reaction. Very important reaction known as aldol condensation. Why? Because this aldehyde is having at least 2 alpha hydrogens. So this will react with its similar amine say aldehyde, that is known as simple intermolecular aldol or self-intermolecular aldol condensation. So the product between these two molecules on treatment with NaOH, that means base, and upon heating will be like this. It will be CH3, then it will be CH, double bond CH, single bond C, double bond O, and then it will be CH3. Sorry, it will be H, not CH3. So this will be the product. This is known as alpha beta unsaturated aldehyde. Similarly, if reaction of this aldehyde takes place with another different type of carbonyl compound, say for example benzaldehyde, in basic medium, then this is known as crossed aldol condensation. So the product will be like this. It will be this ring, and then it will be CH, because oxygen from this and 2 hydrogen from this, that means it will become CHCHO. So no need of heat over here. Why? Because of this aromatic ring, conjugation will be extensive conjugation, hence there will be no need of heat. Otherwise you have to use heat, otherwise aldol condensation cannot take place. But here aldol condensation takes place without heat. I hope these points are very much clear to you. Now let me know quickly, am I clear? Let me know quickly. Am I clear? Let me know quickly. Quickly. Come on, my dear lovely students, quickly. Okay. Do I have to revise NCERT for organic after all these lectures, sir? No need to revise, but try to solve examples and questions from NCERT as well, because that is very important. Okay, now clear. If same aldehyde, remember, if same aldehyde is treated with Schiff's reagent, basically let me tell you, and this is colorless, we have basically Schiff's reagent, we have basically Schiff's dye, that is aqueous rosanilin hydrochloride, and the color of that Schiff's dye is pink. But after passing sulfur dioxide to that dye, it becomes Schiff's reagent, that means colorless. But when this colorless Schiff's reagent is treated with aldehyde, remember pink color is restored. Pink color is restored. That means this reaction can be used as a test or a distinguishing test of aldehyde from ketones. Say under the name Schiff's test. So this was all about say aldehyde. Now we will be having another important compound over here. Have a look. Have a look. Have a look. Have a look. We will be having another important compound, and that is this carboxylic acid. That is this one, carboxylic acid. My dear lovely students, let me show its reactions, but we don't have say space over here, otherwise we have to basically complete all reactions in one say slide. Now complete. Have a look. Have a look now. Have a look now. Have a look. Let me write down over here CH3COOH, or let me write down COH in this fashion. CH3C double bond OOH. Have a look. Very, 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 very important session. Very important session. If you have studied, because you must have studied, as your examination is very near, and that is on 3rd May. So for you people, this is very, very, very important session. The persons which never studied, obviously nothing is important for them. Now, so this is carboxylic acid. Now, if you have carboxylic acid and you treat it with, say for example, base, then acid plus base gives salt. You know that. So it will result in the formation of this one. Similarly, if reaction is of, say for example, NH4OH, base is NH4OH, then it will be an ammonium salt like CH3COONH4. And remember, if this is heated, it will lose water molecule. When it loses water molecule, it will result in the formation of amide. And when amide is obtained, very important reaction of amide is Hoffman bromamide degradation. Already, once we have discussed that, but once again, let me write down over here NaOHBr2 or NaOBr or KOBr. So what will happen? Remove this, you will get CH3NH2. Say you will get amine. Now, after this, if say base is NaHCO3 or base is Na2CO3, sodium bicarbonate or sodium carbonate, what will be the product? CH3COONA and water plus carbon dioxide. Here, brisk effervescence of this carbon dioxide will be observed. Brisk effervescence will be observed over here. That's why this reaction, sodium bicarbonate or sodium carbonate, this reaction can be used as a test to distinguish any acid which is stronger acid than carbonic acid. All those acids show this brisk effervescence, and among those acids which are weaker than carbonic acid generally do not show this reaction, except paranitrophenol, that is weaker acid than carbonic acid, but that can show this brisk effervescence. After this, my dear lovely students, have a look. If this is treated with NH3, it will result in the formation of amide, CH3, C double bond O, NH2. But when? If it is heated. Have a look. If it is treated with ammonia first, it will result in the formation of CH3CONH4 like this. Then upon heating, it results in the formation of amide. So whenever ammonia and heat is together there, so you have to convert directly acid to amide. After that, my dear lovely students, have a look. Have a look. If you simply treat it with alcohol, say for example, alcohol is like this, CH3, CH2OH. In acidic medium, once again an esterification reaction. Here it will be H which will be removed and OH will be removed from this. So we will get CH3CO, OH is removed, here H is removed, then it becomes OCH2CH3, now OCH2CH3, that means ester is formed. Esterification reaction is this. Similarly, if you treat this with CH3COCl, COCl. Now let me show some other reactions because we have done those reactions. Now after this, if you treat with this PCl5 or PCl3, have a look, or SOCl2, thionyl chloride. Replace OH by Cl, then you will get acid chloride like this. Acid chloride like this. But you know, whenever acid chloride is treated with H2, PD, BaSO4 with small amounts of sulfur or quinoline, Rosenmund reduction, you just replace this Cl, by H. So this is Rosenmund's reduction. Now after that, if this carboxylic acid is heated with its another carboxylic acid in presence of P2O5 or concentrated H2SO4, at that time intermolecular dehydration takes place. That means dehydration between two molecules will take place and it will result in the formation of an anhydride. It will result in the formation of an anhydride. After that, my dear lovely students, have a look. So, can I say that acid can be converted to amide, ester, acid chloride, anhydride? I mean, say it's acid derivatives. Have a look. After that, you can simply reduce this by using lithium aluminium hydride followed by hydrolysis, or diborane followed by hydrolysis. Then what will happen? It will result in the formation of CH3, CH2OH. So, carboxylic acids can be converted to alcohol as well. Have a look. These carboxylic acids can be converted to alkane if you use HI in red phosphorus. That means HI red phosphorus can convert almost every say functional group. So it will convert this to CH3. It will remove these oxygens and will add hydrogen. So it can form alkane as well. But if you treat this carboxylic acid with soda lime. So what is soda lime? Soda lime means NaOH and CaO in the ratio of 3:1. You know that. So this is known as awkward process, or this is a decarboxylation reaction, and it will result in the formation of this, plus carbon dioxide will be evolved in the form of Na2CO3. After that, if this carboxylic acid is treated with NaOH, you know, it first results in the formation of CH3COONA. Then this upon treatment with water and electrolysis, that means coal-based electrolysis, what will happen, my dear students? This alkyl group will be dimerized and it will result in the formation of an alkane known as ethane. I hope this is clear to each and every one. After that, my dear students, if this carboxylic acid having at least one alpha hydrogen is treated with chlorine or bromine, say for example halogen, chlorine or bromine in presence of red phosphorus, followed by hydrolysis, reaction is known as Haloalkane reaction. That means HVZ reaction, and this is generally an alpha halo acid is obtained. That means alpha halogenation reaction is this actually. So it will result in the formation of alpha halo acid. If this halogen is taken in excess, then it will replace all these hydrogens at alpha position. Now let me know quickly, am I clear till now? Let me know quickly, am I clear till now? Let me know quickly. Am I clear till now? Okay. Come on, that's great. That is great. Quick, my dear students, quick. As we have to discuss many reactions, and that too in shorter time. Come on, my dear students. Let me know, is this clear till now? Which one is confusing, Rufi Zain? Please let me know. Let me know which one is confusing. Come on. I'm waiting. Which one is confusing? Come on. Let me know which one is confusing. Which reaction is confusing? Is this Haloalkane reaction? Let me know quickly. I'm waiting. Yeah, have a look. It's basically any acid having at least one alpha hydrogen on treatment with halogen red phosphorus followed by hydrolysis. What you have to do, simple. Remove one hydrogen and replace that hydrogen by one halogen. That's it. That is it. You have to replace one hydrogen at alpha position of acid by one halogen. That reaction is known as what we call Haloalkane reaction. But if halogen is taken in excess, then replace another hydrogen by another halogen, then replace another hydrogen by another halogen. I hope this is clear to you. Yes, at the rate of Databani. Confused. About what, my dear lovely student, you have got confused? Okay, Rufizan, got it, sir. Okay, that's great. That is great. This is simple halogenation reaction. Just replace, say hydrogen by halogen. Then God bless you. Don't need to thank me, but I will thank you if you all got selected in, say MBBS. Okay, that's great. That is great. That is great. Is this clear till now? Let me know quickly. Is this clear till now? Let me know quickly so that I will move ahead. Let me know quickly so that I will move ahead. Let me know quickly so that I will move ahead. Okay, that's great. That is great. Which previous step? Which previous step, Databani? Which previous step? Come on. Let me know which previous step, because I am here only for you people. Unacademy is here only for you people. So let me know which step. Come on. Which previous step, my dear lovely student? Which previous step? Yes, you can listen from now as well. These are all, because organic chemistry can be started from anything and it can be ended at anything. It's not that we have to start from alkane. No. Whenever you, say, are studying or discussing convergence, at that time you can take it from anywhere. Sir, I am going to die if I am not selected for MBBS. No. No one dies. I have failed in MBBS, but I have not died. So no one dies. So don't worry. Only one thing in mind. Keep one thing in mind. And that thing is, do your best. God will do the rest. That's it. You have to do your best. Then God will do the rest. Don't worry. If you don't got selected in MBBS, remember, my dear lovely student, then MBBS is basically not for you. Something better is waiting for you then. Remember that. Okay, that's great. That is great. That is great. Come on. So should we move ahead? Should we move ahead? Let me know quickly. Let me know quickly. Let me know quickly. Let me know quickly. At the rate of okay, come on. Okay, let's move ahead. After this we will be having another very important compound. Have a look. We will be having very important compound like this. We will be having very important compound like this. Have a look. If we treat this is very important reaction. Have a look. If we treat this with ammonia, what will happen? If we treat alkyl chloride with ammonia, what will happen? The Cl will be lost, and instead of that, NH2 will be, there. That means Cl will be replaced by NH2. So this is very important compound known as amine. So this amine is also a very important compound, but its further reactions are not possible over here. That's why let us discuss its reactions over here. Let us discuss its reactions over here. So CH3, CH2, NH2. CH3, CH2, NH2. Have a look. Now, first reaction of this amine is in which this amine will act as a nucleophile. Say for example, I will treat it with CH3, say for example X. But let me write down this CH3X in excess. Now what will happen? One hydrogen will be replaced by CH3, another hydrogen will be replaced by CH3. So hydrogens will be replaced by CH3. At nitrogen, hydrogens will be replaced by CH3. First, it will result in the formation of a tertiary amine. But after that, as this is taken in excess, this lone pair will attack CH3 and then another CH3 will be attached to this. Have a look. Let me show over here. So a quaternary ammonium salt to this positive part, X minus will be attracted. This is known as quaternary ammonium salt. Quaternary ammonium salt will be obtained. After this is known as Hoffman homonolysis method. Now, another reaction. If you treat this with an acid chloride, say for example CH3COCl, generally reaction takes place in presence of base, or you can use acetic anhydride, say for example CH3CO whole 2O. Reaction takes place generally in presence of base. Now, what will happen? Replace one H by acetyl group. That means it is acetylation of this amine. So it will result in the formation of CH3, CH2, then it is NH, then it is CO, then it is CH3. So we have to remove hydrogen and we have to add acetyl group. So this is acetylation. Similarly, it can be like this. So acetylation can be taking place either with the help of acetyl chloride, or I mean to say what we call acetic anhydride. After this, my dear lovely student, have a look. We can treat it with chloroform. In basic medium. This reaction is simply known as carbyl amine reaction, carbyl amine test, because here we will get a bad smell compound, isocyanide, isonitrile or carbyl amine, and the electrophile of this reaction is CCl2. I mean say dichlorocarbene is the electrophile of this reaction, you know that. After this, we can treat this with Grignard's reagent, say for example CH3MgBr. But this is having negative part, this is having positive part. This negative part will abstract hydrogen from this, so it will become CH4. So one of the products will be CH4. Then this will result in the formation of CH3, CH2, NH having negative charge. MgBr will be there attracted. Okay, so CH3, CH2, then NH, MgBr will be attracted to this negative part. So this is negative, this is positive. Okay, after this, if this is treated with HNO2, have a look. If this is treated with HNO2, even at 0 to 5 degrees Celsius, it first results in the formation of alkane diazonium salt, but that is not stable, unstable. That's why just remove that and remove this NH2, and instead of NH2 add OH. That's it. So whenever aliphatic primary amines react with nitrous acid, you have to form alcohol. You have to replace this NH2 by OH. You have to form alcohol. But first you just remove this, form a carbocation. If carbocation can undergo rearrangement, rearrange carbocation. After that, finally attach OH to that. Okay. After this, if this is treated with carbon disulfide, have a look and remember one more thing, here nitrogen gas will be obtained. This is the only amine, remember, only amine, aliphatic primary amine is the only amine during which at 0 to 5 degrees Celsius on treatment with nitrous acid results in the formation, or it evolves nitrogen. Only amine which evolves nitrogen on treatment with nitrous acid at a 0 to 5 degrees Celsius is aliphatic primary amine. That's it. Okay. Now, if it is treated with what we call carbon disulfide and we warm it, followed by treatment with HgCl2, then it will result in the formation of CH3CH2. Then N, double bond C, double bond S. This is known as alkyl isothiocyanate. This is ethyl alkyl thiocyanate. Its smell is mustard oil smell. It's having a mustard oil smell, known as Hoffman's mustard oil reaction or Hoffman's mustard oil test. With the help of this test, we can distinguish aliphatic primary amine from rest of the amines or from rest of the compounds. Similarly, if this is treated with phosgene or carbonyl chloride, then what will happen? It will result in the formation of CH3CH2, then NH, then it will be C double bond O, then NH, and then it will be C2H5, or I will write down CH2CH3. So this is ethyl, this is ethyl. So if it is NH2CO NH2, it is urea. This is diethyl urea. Okay. After that, if it is oxidized by using KMNO4, remember it first result in the formation of imine CH3CH double bond NH. Have a look. replace, or you have to remove hydrogen from this, form a double bond. So amine is first formed, but this upon hydrolysis, break this one, add OH over here, HH over here. But if you have two OH groups attached to same carbon, a loss of water takes place and it will result in the formation of an aldehyde. Now, let me know in the chats quickly, am I clear till now? Let me know in the chats quickly, am I clear till now? Let me know quickly. Let me know quickly. Quickly. Let me know quickly. Am I clear? Am I clear till now? Am I clear till now? Come on. Show some josh. Show some, say green hearts. Come on. Because this session, you will see, definitely you will see this, how this session is important for you. You will see that on 3rd May. How important this session was, you will see that on 3rd May. And I once again guarantee you, in organic chemistry, out of 15 to 18, or we can simply say out of 15 questions, at least 10 to 12 questions will come in your NEET paper from this session by one way or the other way. That's my promise to you. Now, come on. Next is, if this amine, have a look, if this amine is treated with Hinz-Burgess reagent. This is Hinz-Burgess reagent. Benzene, say sulfonyl chloride. This is Hinz-Burgess reagent. Then what will happen? It will result in the formation of CH3, CH2, then NH. Then it is S double bond O pH. But this is the solid. But if this solid is treated with alkali, say for example alcoholic potassium hydroxide, what will happen? This OH will abstract this H and it will result in the formation of CH3, CH2, N negative, then S double bond O pH, and this K positive will be attracted towards this N. In nutshell, this reacts with this and forms this. That means this is soluble in KOH. Soluble in KOH. So whenever you use Hinz-Burgess reagent, you can distinguish primary, secondary and tertiary amines. Primary amine reacts with it and results in the formation of a solid, but which is soluble in KOH. Secondary amine reacts with it, forms a solid, but that is insoluble in KOH or alkali. But tertiary amine does not react with it. I hope this is clear till now. This is clear till now. Let me know quickly. Am I clear till now? Quick. Am I clear? Am I clear till now? Let me know quickly. Let me know quickly. Am I clear till now? Am I clear till now? Come on, quickly. Come on, quickly. Am I clear till now? Let me give you some good news, and that good news is that you have completed almost all the organic reactions of aliphatic compounds. Do you know that? Do you know that you have completed almost every reaction related to your aliphatic compounds? You have completed alkenes, say hydrocarbons, you have completed haloalkanes, you have completed say alcohols, you have completed ethers, you have completed what we call different reaction of aldehydes, you have completed ketones, you have completed say carboxylic acid. Sir, but we don't have completed ketone. We have completed aldehyde. We have completed aldehyde. We don't have completed ketone. Remember, with ketone, this can also show the reaction, this can show 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 reaction. That means every reaction can be shown by ketone as well. But here, this is not shown by ketone, this is not shown by ketone, this is not shown by ketone. This can be shown by ketone if it is having methyl group. This can be shown by ketone, this can be shown by ketone, this is not shown by ketone. That means this is the only reaction. This, and these 4 reactions are there which are shown by aldehydes, not by ketones. Otherwise, all other reactions are shown by ketones. Now, come on. Let's have other reactions. Let's have other reactions. But before that, let me take some sip of water as well. Give me a second. Okay. Okay. Now, come on. Let's have a look towards this. Let's have a look towards this. Let's have a look towards this. Let me show you first. Let me show you first. Let me show you first. Have a look. In this, we will be having this one. This one. Now, if this is treated, have a look. If this is treated with, say, for example, bromine in CCl4, then the product formation will be like this: CH2, CH2, then bromine and bromine. But basically, addition of bromine takes place, anti-addition is this. And that means bromine addition takes place from two different sides. Now, this vicinal dibromide or 1,2 dibromoethane is formed over here. This upon treatment with alcoholic potassium hydroxide, listen carefully, undergoes E2 reaction. Say for example, bromine from this, hydrogen from this, and it will result in the formation of vinyl bromide. Now, we will do another E2 reaction over here. We can use alcoholic potassium hydroxide once again, but vinyl halide does not undergo E2 reaction readily. For that, we need a much more stronger base than this. That's why we use sodamide. We use sodamide, and ammonia acts as a solvent there. Now, what will happen? Another E2 reaction takes place. Another E2 reaction will take place. That means consecutive E2 will take place, and it will result in the formation of alkyne. Now, beta, this alkyne is very, very important. This alkyne is very, very, very important. Now, you can add halogen over here. So, you can simply remove pi bonds and add halogens. So, it will result in the formation of tetrahalo, or means say alkane. You can add HX over here, like you have added already HX to alkene, like that. So, few reactions are similar to alkenes. I will not show those reactions. Now, after that, this shows a very, very, very important reaction. So, have a look. This alkyne shows very, very important reaction. And what is that reaction? That is actually cyclic. That is actually cyclic polymerization. That means when this is treated with red hot iron tube, on treatment with red hot iron tube, or we can say at a temperature of 873 Kelvin, we will get, it will trimerizes and it will result in the formation of benzene. It will result in the formation of benzene. Listen carefully. It will result in the formation of benzene. Now, benzene is an aromatic compound. Now, let us see reactions of aromatic compound now. Now, have a look. First important reaction of benzene is, say for example, if we want to add hydrogen, then addition of hydrogen does not take place normally, but in presence of catalyst and high temperature, it will result in the formation of cyclohexane. That means addition will take place by removing these these pi bonds. Now, after that, if I treat this with chlorine and take chlorine in presence of what we call sunlight, then what will happen? Here it will result in the formation of this. This is basically the hexachloride which has been obtained from benzene. That's why this is known as benzene hexachloride. Its another name is lindane. You can say gamexane. You can say 666. This is very important name. This name is due to carbon number is 6, chlorine is 6, and you know every carbon is having one hydrogen. That means hydrogen is also 6. So this is what we call lindane or gamexane or benzahexene, benzene hexachloride or 666. This acts as a pesticide and it is used in agriculture to kill termites, white ants. Okay. But if you want a balanced reaction, then you can see chlorine are there, so you can write down 3 times. Now, similarly, if you use chlorine in excess, in presence of Lewis acid, an electrophilic substitution reaction will take place. This is free radical addition. Now, electrophilic substitution reaction will take place. Then every hydrogen of benzene ring will be replaced by chlorine. But there will be no change in double bond across, say inside this benzene ring. Let me write down double bond. Let me show resonating structure. So only hydrogens will be replaced. So those hydrogens will react with other chlorine, say Cl minus groups. So 6 HCl will be obtained as well. If you want to, say balance the reaction, 6 and 6, 12. That means it should be 6 times Cl2. Now, have a look, my dear students. If you treat this with COHCl in presence of AlCl3 and CuCl, reaction is known as Gattermann-Koch or Gattermann-Koch formylation, Gattermann-Koch reaction, Gattermann-Koch aldehyde synthesis. In nutshell, CHO group is introduced. CHO group at that time is introduced in the benzene ring. Similarly, if you want to treat this with HCnHCl in presence of AlCl3 followed by hydrolysis, once again aldehyde or formyl group is introduced, but this is known as Gattermann formylation. This is not Gattermann-Koch, this is Gattermann formylation or Gattermann aldehyde synthesis. After this, my dear student, you can have a look over here. If you treat this with chlorine or bromine, say for example chlorine in presence of AlCl3, but chlorine is not taken in excess now, then only one hydrogen will be replaced. That means it will be simple free radical, it's simply electrophilic substitution reaction known as halogenation reaction, known as chlorination reaction, because chlorine has been introduced. After that, if you take HNO3, nitric acid and sulfuric acid, so this is known as nitration, and this mixture is known as nitrating mixture. Among this mixture, HNO3 acts as a base and H2SO4 acts as an acid. That means actual acid of this reaction is H2SO4 and electrophile of this reaction is nitronium ion. That nitronium ion will be introduced in the ring. So nitration is this and water will be the side product. After that, you can have other reactions of this. Say for example, you can have this reaction. But remember, this is a reversible reaction, sulfonation. Fuming sulfuric acid can be there, oleum can be there, H2S2O7 can be there. So H2SO4 concentrated can be there. So what you have to do is you have to introduce SO3H finally. Electrophile of this reaction is SO3 in general, neutral SO3, or sometimes you can say SO3H positive is the electrophile, but generally it's SO3. So this is what we call a reversible reaction. After this, if this is treated with alkyl chloride in presence of Lewis acid, CH3 positive will be the electrophile, and this reaction is known as Friedel-Crafts alkylation reaction. You know that. So in this fashion, you can introduce methyl or alkyl group to this. So this is Friedel-Crafts alkylation. After that, Friedel-Crafts acylation can take place by using acetyl chloride in presence of AlCl3 or acetic anhydride, CH3CO whole 2 and then O, acetic anhydride in presence of AlCl3. Then you can use this and product will be same like this, C double bond O CH3. That means acetyl group is introduced. That's why Friedel-Crafts acetylation. This is known as Friedel-Crafts acetylation. After that, if this is treated with V2O5, remember, V2O5 is a strong oxidizing as well as reducing, as well as what we call dehydrating agent. What will happen? First of all, carbon dioxide will be lost, water will be lost, and it will result in the formation of malic acid. First, it will result in the formation of malic acid. But this malic acid in presence of V2O5 undergoes dehydration and it finally results in the formation of malic anhydride. In nutshell, whenever your benzene is treated with V2O5, final product will be malic anhydride. It will be malic anhydride. So, suppose you want malic anhydride. For that, you have to prepare benzene. But for benzene, you have to prepare this one, alkyne. But for alkyne, say for example, your question is like this. Convert, say for example, convert methane into benzene or convert methane into what we call maleic anhydride. What you have to do is simple. Convert first methane into this, I mean say ethyl chloride. Then this ethyl chloride upon elimination will result in the formation of ethene. Then it will form this alkyne. After that, this alkyne, I mean say we have different steps. We have different, I mean say types of reactions, but I am showing you one. Then this alkyne forms benzene. This benzene on treatment with this can form this. These are what we call convergence. So these are very, 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 I mean say easy. Now tell me, am I clear till now? Is everything clear till now? Let me know in the chats quickly. Am I clear till now? Come on. Josh should be very much high. Come on. Let me know quickly. Show some Josh quickly. Come on, my dear students. Show some Josh. Come on. Because this is not the place of chatting. This is the place where you have to learn. Come on. Be with me. Learn things. Come on. Because Unacademy platform is that platform where you have to learn. Come on. Yes, that's great. That is great. Now have a look. Is this, I mean say, clear to you? What is this? This is known as what we call methyl benzene or toluene. Have a look. This is very important compound. Let me show you few reactions of this. This is methyl benzene or what we call toluene. Whenever you have methyl benzene or toluene, remember my dear lovely students, have a look. What should we remember? Have a look. What should we know? Have a look. First of all, we must know that if it is undergoing chlorination or bromination at benzylic position, but controlled chlorination. So I have to replace only two of, I mean say, these hydrogens. After that, it undergoes hydrolysis, whether it is basic hydrolysis or, I mean say, acidic hydrolysis. Let me write down like this. Basic hydrolysis. First, what will happen? Two hydrogens will be replaced by 2Cl. Then 2Cl will be replaced by two OH groups. Two OH groups at one position will lose water molecule and it will result in the formation of Benzaldehyde. Okay. Now, after this, another reaction. Another reaction is with CrO2Cl2. This is known as chromyl chloride. Followed by hydrolysis, it will also result in the formation of benzaldehyde, and this reaction is known as Itard's reaction. This is known as Itard's oxidation or Itard's reaction. After that, my dear students, if you are treating this toluene with chromium trioxide in presence of acetic anhydride, here once again an oxidation will take place and it will result once again in the formation of what we call benzaldehyde, followed by this is first one, followed by hydrolysis. I mean say benzaldehyde will be obtained. But if this is treated with strong oxidizing agents, I have already told you that strong oxidizing agents are KMNO4 in neutral alkaline or acidic medium, K2Cr2O7 in acidic medium, or we can simply say HNO3 in acidic medium. We can say Jones reagent, that means CrO3 plus H2SO4. We can say chromic acid, that means H2CrO4, that means CrO3 plus H2O, that means aqueous, I mean say CrO3. These are the strong oxidizing agents. So with the help of these strong oxidizing agents in acidic medium, if strong oxidizing agent is in basic medium, you have to, I mean say, treat the product after that. You have to, if I mean say strong oxidizing agent is in basic medium, then product form undergoes acidification and final products will be simply like this, that CH3 will be simply replaced and instead of CH3 there will be COOH. Now let me know. Can I say this can also be converted to this by oxidation? By using strong oxidizing agents? Simply. Now, after this carboxylic acid, it can be, I mean to say, treated with NaOH CaO. That means That means decarboxylation can take place. Once again, it can form benzene. Once again, it can form benzene. I hope this is clear till now. Let me know quickly, am I clear till now, so that I will move forwards. Let me know quickly, am I clear till now, so that I can move forwards. Come on. Come on, let me know. Let me know quickly, my dear lovely students. Come on, come on, come on, come on. Now half an hour, only half an hour will be there, so that we will complete our all organic reactions. 10 to 12 questions at least. Come on. Come on, come on, come on, come on. Tell me. Okay. Kanmani, clear sir. Jaya, clear sir. Ready. At the rate of V ready. Yes sir. At the rate of Zahra. Yes sir. At the rate of Vishwa. Yes sir. Okay. At the rate of Excel Gamer. Great. At the rate of Rufizane. Yes sir. Great. At the rate of Thornbolt. Stars. Thank you. God bless you. At the rate of Surya Dev. Green Heart. Nice. Thank you. At the rate of Vishwa. Clear sir. Show some Josh. Show some Josh. Come on. Josh should not be low. Josh should be very much high. Your Josh should be very, very, very high. Come on. Come on, come on, come on, come on. Let me know quickly. Let me know quickly. Let me know quickly. Let me put my mobile over here. Come on. Come on, come on, come on. Now, next. Next, our important compound is, among these, all are important, but this is very, 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 very important compound. Chlorobenzene. So, let us do few reactions of chlorobenzene. Let us do some reactions of chlorobenzene. Come on. Let's do some reactions of chlorobenzene. Come on, come on, come on, come on. You have to check your amine say preparation. You have to check your preparation. Come on. If this is treated with magnesium in presence of tetrahydrofuran, what is the function of this magnesium? Magnesium will be simply incorporated between C and Mg. So we will get phenyl magnesium chloride. I mean, say we will get simply Grignard's reagent. Now we know this phenyl part will be having negative charge and MgCl will be having positive charge. Means if this is treated with acidic hydrogen containing compound, say for example water will lose H positive, this phenyl will accept that H positive and it will form benzene ring. Plus it will be MgCl and OH. That means hydroxy magnesium chloride. After that, very, very important reaction. On treatment with NaOH at a temperature of 623 Kelvin at a pressure of 300 atmospheric, followed by acidification, results in the formation of phenol known as Dow's process. Very, very, very important reaction known as Dow's process. After that, after this reaction, you can simply have its chlorination or bromination. Say for example chlorination. Then you know here electrophile is Cl positive and that Cl positive will go to ring where electron density is more, and we know this is basically the halogen, and halogens because of resonance increases electron density at ortho and para position, so its products will be 1,2-dichlorobenzene and 1,4-dichlorobenzene. That means ortho as well as para products are there, but para will be major. Ortho will be minor because of repulsion. Similarly, nitration of this chlorobenzene with the help of nitrating mixture. So NO2 positive is the electrophile. Where electrophile goes? Once again to ortho or para position. And product will be like this. So once again para will be major, ortho will be minor. After that, sulfonation, but remember sulfonation is a reversible reaction. So electrophile generally is SO3. So SO3 will go to either ortho or to para. Finally it becomes SO3H. So sulfonation reaction takes place like this. So para SO3H product. Okay? Para will be major, this will be minor. Para will be major, this will be minor. Let me show some other reactions on next slide. But before that, let me know quickly. Let me know quickly. Am I clear till now? Let me know quickly. Am I clear till now? Let me know quickly. Am I clear till now? Quick. Quick, 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 quick. Let me know. Let me know quickly. Let me know in the chats. Am I clear, my dear lovely students? Come on. Okay, show some josh, show some green hearts as well, so that I will be much more motivated. Come on. Come on, come on, come on. Your response is very much important for teacher, because when you respond, we will get, boosted at that time. So, come on. Come on. Show some josh, show some josh. Great. That is great. That is great. Now, after sulfonation, let me show other reactions of chlorobenzene. Let me show other reactions of chlorobenzene. Have a look. Let me show other reactions of chlorobenzene. Have a look. Another reaction of chlorobenzene is Friedel-Crafts alkylation simply. Suppose CH3Cl in presence of AlCl3. We know the electrophile of this reaction is CH3 positive, and that CH3 positive electrophile will go either to ortho or to para. Either to ortho or to para. But para 1 will be the major product. Para 1 will be the major product. So this is major and this is minor. Now, after that, Friedel-Crafts acylation. Say, for example, CH3COCl, AlCl3, or you can use anhydride as well. Say CH3CO, whole 2O. But let me write down acetyl chloride over here. So what will be the product? Acetylation will take place. That means C double bond O CH3 will come either to ortho or to para position. But we know ortho will be minor, para will be major, because in ortho there will be more repulsions. Hence, this will be the product. So this will be the major product. This will be the minor product. After this, if this, say haloarine is treated with sodium in presence of dry ether, we know it will result in the formation of a major product like this, biphenyl, and reaction is known as Fittig reaction. If you treat alkyl chloride with sodium, that is known as Wurtz reaction. If you treat aryl halide, then it is known as Fittig reaction. And if you treat both aryl halide as well as alkyl halide with sodium in dry ether, that reaction is known as Wurtz-Fittig reaction, and the major product of Wurtz-Fittig reaction will be this one. This is Wurtz-Fittig reaction. After that, my dear lovely students, if you have chlorobenzene and you treat it with chloral, if you treat it with chloral, say trichloroacetaldehyde or say ethanol in presence of H2SO4 or acid, then this will be the product. We know here two molecules of chlorobenzene react and results in the formation of this product, and this product is known as what we call DDT, diphenyl trichloroethane, and this is used as an insecticide, and it is very effective against Anopheles mosquitoes and lice, which can cause malaria or what we call typhus. But remember, this is non-biodegradable. It has already banned in USA. So this is not, advised to use. Now, let me know quickly. Am I clear till now? Let me know. Yes, at the rate of Vicky. Exactly, it's DDT. Come on. Come on. Yes, obviously, if you have understood organic chemistry, then why can't you solve the questions? Because this is actual organic chemistry. This is all the reactions have been involved over here. But yes, you have your basic should be, strong as well. So this is for your revisions. This is for your revision so that you can revise your organic chemistry. Say for example, your NEET examination is on 3rd. You can check out this quickly at 1.5 say speed, or you can check out this in within 2 hours. Say you will revise whole organic chemistry. So this is very, very effective for you. So it will take maximum 10 to 20 minutes, I think so. 20 minutes more, 20 minutes more. You can simply say that 20 minutes, within 20 minutes or 25 minutes, every, say reaction will be done and dusted. Now, come on, let's have another molecule, and that molecule is this one. Let's have a reaction of this, very, very important, phenol. Very, very important, phenol. Let's have phenol. Let's have phenol over here. This is phenol. This is phenol. Now, if you are having a phenol, then which type of reaction phenol can show? Have a look. Phenol on treatment with sodium can result in the formation of sodium phenoxide. Active metal, on treatment with active metal, it can form phenoxide of that metal. On treatment with active metal, it can form phenoxide of that metal, as well as hydrogen gas will be evolved. Hydrogen gas will be evolved. Now, after that, if it is treated with NaOH, it will result in the formation of salt. That means once again a sodium phenoxide is obtained. But at the very same time, water will be obtained over here. Now, after that, if this phenol is treated with CH3COOH in presence of acidic medium, then replace OH from say acid and H from phenol, you can simply form CH3 C double bond O, say of this, then O of this, and then phenyl ring, say ester is formed. So this is esterification. Similarly, if you treat this with CH3COCl, in presence of, generally reaction takes place in presence of pyridine, then replace this H by COCH3. That means it will be simply CH3CO. Then replace this H by this. That means write down OPH. Once again an ester. This is basically a removal of, say phenol has been taken place, and after that this acetyl group has been introduced. So this is acetylation. Similarly, acetylation can be taken place with the help of CH3 CO whole 2 O. Say this is acetic anhydride pyridine. Such reactions, we have already completed such reactions, but in alcohol, have a look. But in alcohol, where is the reaction? Where is the reaction of alcohol. Just a moment. These are the reactions of alcohol. Have a look. Alcohol on treatment with acetyl chloride and anhydride. What has happened? Remove hydrogen of this by acetyl. Similar type of reaction in phenol. My dear lovely students. Have a look. What we have to do is, we have to introduce this acetyl instead of this H. That means we have to replace H by means of phenol. Now, if the value of this alkyl is C6H5, then COCl, then this is known as benzoylation. Because now COC6H5 will replace this H. That means C6H5CO is known as benzoyl group. This is acetyl. So acetylation, resulting in the formation of ester, so esterification. So this is benzoylation. So benzylation of phenol has been taken place by using benzoyl chloride. Benzylation of any acidic hydrogen containing compound by using benzoyl chloride is known as Schotten-Baumann reaction. That reaction is known as Schotten or Schotten-Baumann reaction. After that, my dear lovely students, have a look. These reactions were because of this, say hydrogen. Then there will be reactions because of OH group. But generally, phenols do not show such reactions. Alcohols show such reactions. After that, we will be having few reactions. For example, we will be having oxidation. We will be having reduction. Say, for example, if we treat it with zinc and heat, then oxygen will be lost and it will result in the formation of benzene. there will be oxidation reaction as well. Say for example, strong oxidizing agent, for example, sodium dichromate, potassium dichromate in acidic medium. What will be the product? Product will be parabenzoquinone or benzoquinone. So parabenzoquinone will be the oxidation product. After that, we will be having its, electrophilic substitution reactions as well. But those electrophilic substitution reactions will be discussed on what we call another slide. But before that, let me know in the chats, am I clear? But before that, let me know in the chats, am I clear? Let me know in the chats, am I clear? Quick. I'm waiting. Let me know. Let me know in the chats, am I clear till now? I am waiting, my dear lovely students. Come on. Come on. I'm waiting. Thank you, Ajay. Thank you, Vishwa. Thank you, Rufi. Thank you, @VRuddy. Great. That is great. Now have a look. Now, if you have a phenol, its other important reactions of phenol are, have a look. You will be having few important reactions of phenol, like, if phenol is treated with bromine, for example, halogenation, but in non-polar solvent, then we will get monobrominated product. That means we will get ortho as well as parabromophenol. And major product will be para. Minor will be ortho. After that, if this phenol is treated with bromine water, that means solvent is water now, then we know we will get 2,4,6 tribromophenol. White precipitate of 2,4,6 tribromophenol will be obtained, but alcohols cannot show white precipitate, so this reaction can be used to distinguish, alcohol from phenols or phenol from alcohols. Now, after that, you can use dilute HNO3. That means dilute HNO3 can also, show nitration of phenol. Then what will be the product? Product will be orthonitrophenol and paranitrophenol. But here, para 1 will not be the major, ortho 1 will be major because of intramolecular hydrogen bonding or chelation taking place between hydrogen and oxygen. So this will become minor. But if nitration takes place with the help of concentrated HNO3 in presence of sulfuric acid or concentrated HNO3, if nitration of phenol takes place in presence of concentrated HNO3 or concentrated HNO3 in presence of H2SO4, then we will get picric acid. That means 2,4,6 trinitrophenol will be the product. 2,4,6 trinitrophenol will be the product. But if you have a look over here, its yield will be low. It's present in low yield. Picric acid will be obtained, but in low yield. If you want to increase its yield, you have to first convert or treat this with sulfuric acid, say for example with 2 moles, then it will result. Nowadays, it first results in the formation of this one, phenol 2,4-disulfonic acid. Then this is treated with nitric acid. Then these sulfonic acid groups will be replaced and nitration will take place, and we will get once again a picric acid. But here, yield of picric acid will be more. Here, it will be present in high yield. That means we can increase yield of picric acid with the help of this. Okay. After this, we have few more reactions of phenol. Let's do those reactions as well. Have a look. This is phenol. On treatment with sulfuric acid, as this reaction is reversible, so you can write down sulfuric acid. You can say with the help of sulfuric acid you can form this, but if sulfuric acid is there, you can form these products as well. I mean to say ortho as well as para products. Ortho as well as para products. But you have to remember, activation energy for this product is low and activation energy for this product is high. That means this is measured at low temperature. This is kinetically controlled product and this is thermodynamically controlled product. This is measured at low temperature. This is measured at high temperature. Now, after that, if phenol is treated with NaOH, then carbon dioxide followed by acidification, here we will get orthohydroxybenzoic acid known as salicylic acid as the major product, and reaction is known as Kolbe reaction. This is known as Kolbe reaction, or this is known as Kolbe-Schmidt reaction or carboxylation of phenol. Remember, if this is treated further with either acetic anhydride or acetyl chloride, then this H of this phenol will be replaced by CO group. That means acetylation will take place and it will result in the formation of acetyl salicylic acid. This is known as acetyl salicylic acid because in salicylic acid we have introduced acetyl. So this is acetyl salicylic acid, or this is known as acetyl and oxygen combined together. So this is known as acetoxic benzoic acid. This is commonly known as aspirin. And this aspirin can be used as an analgesic, that means pain reliever, and antipyretic, that means it can bring down the body temperature, antipyretic or febrifuge. Now, after this, if this phenol is treated with chloroform first in basic medium, followed by acidification, then we will get acetaldehyde as major product. That means we will get orthohydroxybenzaldehyde known as salicylaldehyde, not acetaldehyde, known as salicylaldehyde. So orthohydroxybenzaldehyde, commonly known as salicylaldehyde, as the major product. But if same reaction, and reaction is known as Riemann-Simon reaction, here dichlorocarbene acts as an electrophile. Now, after this, if you use CCl4 instead of CHCl3 in the same reaction, but instead of CHCl3, I mean say chloroform, you use CCl4, then we will get salicylic acid as the major product instead of salicylaldehyde. So salicylic acid as major product instead of salicylaldehyde. But in this reaction, dichlorocarbene is not an electrophile. CCl4 will act as an electrophile. After that, if this is treated with NaNO2, H2SO4, remember, or HNO2 in presence of H2SO4, then it results first in the formation of this one. And this is known as indophenol. This is known as indophenol, which upon treatment with NaOH loses water molecule because this OH minus will abstract this H, and it will result in the formation of sodium salt of indophenol. It will result in the formation of sodium salt of indophenol. Sodium salt of indophenol is blue in color. Indophenol. So with the help of this, we can distinguish phenol and alcohol, because phenol shows this reaction, alcohol do not show this reaction. I hope this is clear till now. Now, am I clear till now? Quickly, let me know in the chats, but quickly. Very quickly. Let me know in the chats very quickly. Am I clear till now? Am I clear till now? My dear lovely students, quickly. Okay. Come on. Come on, show some Josh quickly. That's great. That is great. That is great. That is great. That is great, my dear lovely students. Okay. Okay. Come on. Now we have another very important, species, and that species is Benzaldehyde. That species is Benzaldehyde. Why that's important? Have a look. Why that is important? Have a look. Another important species is Benzaldehyde. Why this is important? Have a look. Because with the help of this, we can perform a very important reaction known as Cannizzaro reaction. This is an aldehyde without alpha hydrogen. So it will undergo simple, Cannizzaro or simple or self-intermolecular Cannizzaro reaction in which one molecule will be oxidized and another will be reduced. One will be oxidized to COO minus and Na positive of this, and another will be reduced to, benzyl alcohol like this. So this is known as what we call Cannizzaro reaction, but intermolecular Cannizzaro reaction, and that too self. But if we want to perform crossed Cannizzaro, then both the aldehydes do not have, both these aldehydes should not have any, alpha hydrogen. Then what will be the product? This is more reactive towards nucleophilic addition reaction. This is less. One which is more reactive towards nucleophilic addition reaction is oxidized, and the another one which is less reactive towards nucleophilic reaction or nucleophilic addition reaction is reduced. So it will be like this. After that, if this benzaldehyde undergoes self-condensation, that means it reacts with another same molecule in presence of alcoholic potassium cyanide, then it will result in the formation of a product like this. Have a look. It will result in the formation of product like this. Main functional group is this. So this is alpha hydroxy ketone obtained from benzaldehyde is known as benzoin. Hence reaction is known as benzoin condensation. This reaction is known as benzoin condensation. Now you can simply perform nitration over here as well, electrophilic substitution reaction. But remember, this CHO group is electron withdrawing. It deactivates the ring. That means nitration will not take place easily. But once it takes place, after that, nitronium ion, that means an electrophile of this, will simply go to meta position. It will go to meta position. It will go to meta position. So NO2 will be introduced to meta position, plus it will be H2O. That will be the side product. Now let me know quickly, am I clear? Let me know quickly, am I clear? Let me know quickly, am I clear? Am I clear? Let me know quickly. Let me know quickly. Quickly. Let me know quickly. Let me know quickly, am I clear? Okay. Now, and very important reaction given in NCRT, given in your NCRT as well, and that is whenever benzaldehyde is treated with acetophenone. Have a look, my dear lovely students, have a look. This and this. These, one is aldehyde, another is ketone. That means two different carbonyl compounds. But this is having alpha hydrogen, this is not having. If both does not have, any alpha hydrogen, then Cannizzaro. But if one is having, another is not having, at that time in presence of NaOH or base, it undergoes cross-aldol condensation. Cross-aldol condensation, not Cannizzaro reaction. So what will happen? Have a look. Product of this reaction will be simply CH, because oxygen from this and two alpha hydrogens from this. So it will result in the formation of benzyl acetone like this. Benzyl acetophenone. So it is benzyl acetophenone, or we can simply say it is alpha beta unsaturated ketone which is obtained. So this is cross-aldol condensation. After this we will be having a very important compound, and that compound is known as nitrobenzene. Whenever you are having nitrobenzene, remember this upon reduction, say for example by using what we call active metal in acidic medium, it first results in the formation of aniline. Now if this nitrobenzene is treated with lithium aluminium hydride, then remember it will result in the formation of azobenzene. It will result in the formation of azobenzene. But if same reaction, say same substrate nitrobenzene is treated with zinc ammonium chloride, say neutral medium, it will result in the formation of hydroxylamine, NHOH. This is N-phenyl hydroxylamine. This upon treatment with Tollens reagent, can form nitroso, and silver will be precipitated out in the form of silver mirror. Now that means Ag positive to Ag, that means gain of electron, reduction has been taken place, but reduction of Tollens reagent has been taken place, oxidation of this has been taken place because removal of hydrogen has been taken place. So that's why this also shows Tollens test. Okay. After that, if this is treated with, if this undergoes electrolytic reduction in weakly acidic medium, then it will result in the formation of aniline. If it undergoes electrolytic reduction in strongly acidic medium, then it will first result in the formation of hydroxylamine, but this rearranges. That means this will not be isolated, but our main product which can be isolated in this condition is para-aminophenol. I hope this is clear to you. Sometimes it is like this. You will be having two nitro groups. In same ring. Then at that time, ammonium sulfide, that means sulfide, or sodium sulfide, or sodium bisulfide, say sulfides or polysulfides can be used to reduce only one. That means selective reduction takes place. At that time, you will get one will be reduced, another will not be reduced. This reaction is known as selective reduction, or this is known as Zenin reduction. So among these, this is very important compound. So let's have another reaction, but that reaction will be of aniline. But before that, let me know in the chats. Am I clear? Let me know in the chats. Am I clear? Let me know quickly. I am waiting for your response. Come on. You should be very much sincere because your exam is on 3rd May and 10 to 12 questions will be asked from this session. It's my promise to you. 10 to 12 questions of organic chemistry out of 15 will be from this session. I promise you, I guarantee you this. If any bio, I won't get selected, bro. Okay, what is meant by this? I can't understand. Okay. Now, this will be, say the compound which we will be discussing. And after this, benzene diazonium chloride, and that's it. Now, this is, say an amine on treatment with. Have a look, my dear lovely students. These amines on treatment with, have a look. These amines, if undergo bromination, say for example bromination, then what will happen? It will result in the formation of a white precipitate of 2,4,6 tribromoaniline. 2,4,6-tribromoaniline. White precipitate of 2,4,6-tribromoaniline will be, obtained there. If it is treated with nitric acid and sulfuric acid, then what will happen? It will result in the formation of ortho, meta as well as para product. But ortho will be only 2%, meta will be 47%. That means meta will be more than, ortho. meta will be 47%, that means more than ortho. And finally, there will be para, which will be the major product. And para will be, my dear lovely students, para will be 51%. Para will be 51%. That means that will be the major product. But our expected product should be this and this. But how this has been formed, it is basically this aniline in acidic medium forms anilinium ion, which is meta-directing. That's why this is formed. So if you don't want to form this one, then aniline should not be, obtained. But when should, whenever you react this aniline with, acidic medium, anilinium ion will always be obtained. Why? Because it will give H positive, and this is very electron donating species. That's why we have to decrease its electron density. Now have a look how to decrease its electron density, how to protect this group so that it cannot attack H positive. Have a look. We will first of all do acetylation of this. We will first of all do acetylation of this. That means we will remove H. We will remove H of aniline, and it will result in the formation of this one, acetylated aniline. Acetylated aniline. Now this acetylated aniline is attached to acetyl group, and acetyl group will withdraw electron from this aniline. Its electron density will decrease. Now it can donate now electron to benzene, but lesser as compared to aniline. That is why if now we do this reaction, what we call this one, HNO3 nitration reaction, if we want to perform this nitration reaction now, our nitronium ion will go either to ortho or to para, but para 1 will be the major product. That is why I will show simply para 1. This will be major product. After this, now deacetylation or hydrolysis will take place. That means break this one, add OH over here, H over here. So our major product will be like this. So it can be NH2, then it will be NO2. Similarly, you can form ortho as well, but there will be no meta at all. There will be no meta at all. This is known as this step is known as protection. After that reaction you want to perform, and then what we call deacetylation or hydrolysis. After that, if you want to perform sulfonation, first of all, in acidic medium it forms anilinium ion once again. Once anilinium ion is formed, then SO3H can be attached to meta position as well. That means ortho, meta, para, all products can be formed. But remember, when ortho, meta, para will be formed, most stable will be para 1. That means thermodynamically controlled is para 1. That is why we heat this product. We heat, this sulfonation takes place at high temperature. Say for example 453 to 473 Kelvin. That means at high temperature, what will happen? It rearranges. As sulfonation is basically what we call reversible reaction, meta product is less stable as compared to para. So both are in equilibrium with respect to each other. That's why meta will be converted to para, because para is the more stable product. That's why it will result in the formation of dipolar ion first of para, Zwitter ion. Then these two will form para-aminosulfonic acid. Hence, major product of this reaction is what we call para product, known as sulfanilic acid. I hope this is clear to each and everyone. Let me know quickly in the chats, is this clear to you? After this, if this is treated with NaNO2 and acid, say for example HCl, or HNO2 in excess of acid, but at a temperature of 0 to 5 degrees Celsius, it results in the formation of benzene diazonium salt, and this reaction is known as, or let me write down directly like this, N2. This is known as diazotization reaction. But remember, 0 to 5 degrees Celsius, up to 0 to 5 degrees Celsius, this is stable. If temperature is increased, then this is not stable, it gets decomposed. This is not stable above 5 degrees Celsius. Now, let me know quickly in the chats, am I clear till now? Let me know quickly, am I clear till now? Let me know quickly, am I clear till now? My dear students, let me know quickly. Am I clear? Am I clear till now? Let me know quickly. Okay. Okay, okay. Now, this is a very important compound known as benzene diazonium salts. So, let's have few reactions of benzene diazonium salts over here. This is known as what we call benzene diazonium salt. This is benzene diazonium salt. Have a look, have a look, have a look. Have a look. First of all, whenever benzene diazonium salt is treated with H3PO2, phosphenic acid and water, or ethanol, CH3CH2OH, just remove this nitrogen and instead of nitrogen introduce H. Let me show you that H so that you will remember what has happened basically. You have to remove nitrogen. Nitrogen gas will be evolved and instead of that H has been introduced. That means you can convert benzene diazonium salt to benzene. Have a look. After that, if you heat this above 5 degrees Celsius with water, then N2 will be replaced and OH will take the place of this N2 group. After that, if this is treated with, say for example, Cu2Cl2 or CuCl HCl, then chlorine attached to copper is introduced over here and N2 will be replaced. Similarly, if you take Cu2Br2 or CuBr instead of CuCl, then bromobenzene will be obtained. Similarly, my dear lovely student, if you use CuCN and KCN, then cyanide will take position of N2. That means this N2 will be replaced by such groups. This, these type of reaction, this or this is known as Sand-Meyer's reaction. You know that. Sand-Meyer's reaction is this. This is Sand-Meyer's reaction. After that, my dear lovely student, have a look. If you use copper powder instead of cuprous halide, you use copper powder, then what will be the product over here? Once again, chlorobenzene and bromobenzene will be obtained. Chlorobenzene and bromobenzene will be obtained over here. Chlorobenzene and bromobenzene will be obtained over here, but reaction is known as Gedermann's reaction. Gedermann's reaction. But here yield will be low as compared to Sand-Meyer's reaction. That means chlorobenzene or bromobenzene prepared from benzene diazonium salt by means of Sand-Meyer reaction will be preferred over Gedermann's reaction, because in Gedermann's reaction yield will be low. After this, if you treat this with Ki, aqueous Ki, and you warm this, then this N2 will be replaced by I, so iodobenzene will be the product. Similarly, if you treat it with HBF4, this Cl minus will be replaced by BF4 minus. That means we will get benzene diazonium tetrafluoroborate instead of benzene diazonium chloride. After this, my dear lovely student, if this is heated, then it will result in the formation of what we call fluorobenzene, and reaction is known as Bals-Schimann reaction. Bals-Schimann reaction. This is fluorobenzene. That means here it will be a fluorine. So Bals-Schimann reaction. Similarly, this can be treated with NaNO2, and then this N2 will be replaced. This N2 will be replaced by NO2. That means we will get nitrobenzene. We will get nitrobenzene over here. I hope this is clear. Few more reactions are there. Let me show those reactions on next slide and let us conclude the whole organic reactions then. Now, let me know. Yes, exactly at the rate of V ready, Sand-Meyer is preferred over Gedermann, because in Gedermann reaction, yield of chlorobenzene and bromobenzene is very low. Now, let me know quickly. What about duration? Just 5 minutes, my dear lovely student. At the rate of Kanmani, only 5 or 7 minutes maximum. Only 5 minutes. Now, quick. Quick, is this clear? Is this clear, everyone? Now, after this, let us have other reactions like this. Benzene diazonium salt. Benzene diazonium salt is there. Now, after that, what will happen? Have a look. Have a look. If this is treated with, if benzene diazonium salt is treated with sodium arsenide Na3ASO3 followed by acidification, say for example dilute HCl, then this N2 group will be replaced by ASO3H2. ASO3H2 is known as what we call arsenic acid group. This is known as arsenic acid group, and reaction is known as Barth reaction. If reaction takes place with benzene, I mean say aromatic compound, benzene diazonium chloride and aromatic compound in presence of basic medium, then this benzene part will be attached to this after removing N2, but remember it should be attached at para position. It can be attached at any position, but suppose if it is having any group, then para position with respect to that group should be attached, whether that group is, I mean say, electron donating or whether that group is electron withdrawing. So the product of this reaction will be like this. Or let me show, say for example, if you are having nitrobenzene, so group is there. So with respect to para position with respect to group should be attached. So it will result in the formation of this one. So this is nitro, this is para. So attach this, couple this with this ring. So this reaction is known as, and N2 will be obviously evolved over here. This reaction is known as Gomberg-Bachmann reaction. This is Gomberg-Bachmann reaction. After this, if you have a reaction like, say for example, you have SnCl2, HCl, or you are having Na, say for example, 2SO3, sodium sulfite, then this N2 is retained now. That means it results in the formation of phenylhydrazine. This is phenyl, this is hydrazine, phenylhydrazine. Nitrogen group is retained. But if you use a vigorous reducing agent or a strong reducing agent like zinc HCl, then it will result in the formation of aniline then. After that, if it is treated with phenol, if benzene diazonium salt is treated with phenol in basic medium, then coupling will take place, and reaction is known as coupling reaction at that time. Coupling of this benzene diazonium group will take place at para position with respect to phenol, and this is known as hydroxyazobenzene, and its color is orange. So this is an orange dye, para-hydroxyazobenzene, or we can simply call it as 4-hydroxyazobenzene. Similarly, if reaction takes place with what we call aniline, once again reaction is known as coupling reaction, but with aniline coupling takes place at para position but in acidic medium, then we will get this one. And this is known as para-aminoazobenzene or 4-aminoazobenzene, and its color is yellow color. So this is a yellow dye. I hope this is clear to each and everyone. Let me know in the chats. Is this clear? Is this clear? Let me know in the chats quickly. I am waiting for your response. So this is, I mean to say, this is from my side. This is from my side to you all, because patience is very, very, very important, and I hope you have shown a very good patience over here. So, may God bless you all. This is all about today's session. So, this was from my side, and you have seen that we have touched each and every organic reaction in this session. So I hope you enjoyed the session, you loved this session. Yes, Ajay is showing very much, I mean, say green hearts as well as fire emojis. Thank you very much, Ajay. Thank you, Kanmani. Thank you. Thank you, Rufi Zain. But I will be waiting. I will be eagerly waiting for you after, once this session is ended, after end of this session, I will be eagerly waiting for your comments. I will be eagerly waiting from which place you were watching, because that gives me a confidence that everyone or that students are watching from, I mean, say different areas of this country. So I will be waiting for your comment, but after I end this session. So take care you all and love you all. So bye bye.